guys, Mr. Stevens here with another probability lesson. This time we're looking at two-step experiments. Initially we looked at simple experiments like rolling a dice that only had one step. Now in these kinds of questions we're going to be talking about in this lesson, we're going to be talking about experiments, say for example rolling a dice twice or flipping a coin twice. And we'll also look at some examples of two-step experiments where, say, we're selecting a letter from a word and then selecting a second letter from the word. And we'll look at the probability and what happens to the probability when you replace or don't replace that first letter that you take out. And again, we're going to be looking at some different ways of representing this probability data as well. That's going to be arrays and tree diagrams. And I think, again, a good way to learn about arrays and tree diagrams is just to work with them in some examples. So this is an example of an array when we're tossing a coin twice, or it says tossing two coins. So the way you read this array is you have the result of toss 1 here being either a head or a tail. And then you have the result of toss 2 here being either a head or a tail. So what we're going to be writing in these 4 boxes are the 4 possible outcomes of the experiment. You have one possible outcome here of getting heads on both throws. So that means on toss 1 we got a head, and on toss 2 we got a head. Get rid of this box. And then over here in this cell, on throw 1 we got a tail, but then on toss 2 we got a head. Here on toss 1 we got a head, and on toss 2 we got a tail, and then in this box both options were tails. Okay, that's how we use an array for a two-step experiment. We read off from the first column here, toss 1, and from the second column here, toss 2. And the same thing over here. The result here is for toss 1, tails, and the result here is toss 2. Let's calculate some probabilities. Probability of getting head then tail. And this is how we write the probability of a two-step experiment. What we're specifically looking at here is the probability of getting a head on the first throw and a tail on the second throw. The columns that we were looking at just then, down here, apply equally here when we're writing out a probability. The order is important here. So anyway, the probability of getting a head and then a tail. If we look down in our array, there is one option where we got a head and then a tail. And there are 4 possible options. Now, this next one, this is where these probability calculations get a bit more interesting. The probability of getting one head. Okay, so now the order doesn't matter. As long as there is a H, there is one H in the result, we have a favourable outcome. And there are 2 results, this one and this one, that have one head in the outcome. So there are 2 favourable outcomes, 4 total outcomes, so the probability of getting one head is actually 50%, is half. Now, the other thing we can do in these two-step experiments is we can take a letter at random from a word, and then we can not put it back before we choose the next one. So what that does is that means in our array, all of the options here where we would select T twice, or R twice, or the first E twice, or the second E twice, all those options are now impossible. Because when we select a letter, we don't put it back into the pool before we select our second letter. But the table works in the same way. Here along the top we have our first choice, and here along the side we have our second choice. So if on our first choice we get an R, and on our second choice we get a T, we write it like that. If on our first choice we get an E, and then second we get a T, we write it like this, and so on. The first choice is represented first, and then the second choice is represented second. So down this column, all the first choices will be T's. Across this row, all the first choices will be R. And so on. Okay, now let's do some probabilities. Probability of both letters being E. Ooh. So of these options, there are two where both the letters are E. And now we can count up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There are 12 possible options. So the probability of both being E are 2 over 12 or 1 over 6. Now the probability that there is one E somewhere in the result, now we have to count up all the instances of there being a single E. 1, 2, 3, 4, 5, 6, 7, 8. So that probability is 8 over 12 or 2 over 3. And that's how we use an array table to calculate a two-step probability.